and welcome to Geospatial Survey and Mapping webinar on learning how to use UAVs in land survey speedily and accurately with AIBLOB. My name is Sudha and I'm Executive Editor of Geospatial Survey and Mapping and the coordinator of this webinar. Geospatial Survey and Mapping has been regularly publishing e-magazine covering geospatial technology and their applications. It is the leading source of information for topics related to geospatial technology in the field of survey and mapping. It publishes news, articles, interview, podcast, and tenders. Today we have George Jacob from AIBLOB. George will be giving us a brief introduction to AIBLOB. Then he will be taking us and their possible usage. Participants are requested to put their questions in the question box. The questions will be taken at the end of the webinar. Over to you, George.
Thank you, Sonu. Good morning, everybody. If I can I'll just take my screen. Here we go, show my screen. Okay, so what I'm going to do today is just take you through a quick presentation about AIBLOB and then demonstrate some of the data that we have collected and the different kinds of uses. So AIBLOB is a company based in Bangalore. What we've got, sorry, let me go back a bit. We're using UAVs to collect imagery as well as LiDAR. Benefit of using UAVs is, as you can see, the high resolution imagery. Just to give you guys an idea of where we came up with the name AIBLOB. AI stands for artificial intelligence. Blob is a term used for binary large objects or data, and that's how we came up with AIBLOB. Our key verticals are infrastructure, surveying, mining, advertising, utilities, construction, precision agriculture, forestry, and wildlife. Just an idea of what we do, we work with our end customer to understand their requirements, and then we have the option to build, operate, or transfer the technology to the customer. We have several trained UAV pilots for our fixed wing as well as our rotary wing aircraft. With a certified commercial pilot on board, we have training sessions where we can train pilots for our clients. We own and operate software for flight planning, the execution, aerial triangulation, DEM, DSM, orthomosaics, etc. And since we build our own UAVs, we have the capability of customizing UAVs to a specific need of our customers. In 2015 as a private limited, 100% shareholding by Indians. However, in saying that, I should mention that the research and development for our aircraft has been going on for the past 7 years. It's about a little over a year and a half ago that we were finally mission ready with our aircraft, which is why we decided to go ahead and publicly come out with our company. We're based in Bangalore. We also have offices in Calcutta and New Delhi. The Silver Bee is our fixed wing aircraft. The team, now our team is comprised of people from the engineering, 3D modeling, urban planning, geospatial background, as well as people who are from the unmanned autonomous vehicles industry. Just a quick comparison between using imagery from a UAV versus a satellite. You got flexibility in the image scale, whereas when you're using a satellite, it's really medium scale mapping, so you don't really get very high resolution data. You can use UAV imagery for large scale mapping. Satellite images, you're stuck with medium scale data sets. LiDAR data sets are, you can collect LiDAR using a UAV, whereas you can't do that from a satellite. Temporal updates, if people want periodical updates for smaller areas, it gets very cost effective trying to do that with the UAV. Whereas if you want to do it with the satellite, there's a longer waiting period to collect the imagery because India. Using a UAV, you can collect cloud-free imagery. That's a challenge when using satellites. Traditional aerial photography is definitely way cheaper than using satellite imagery, just because you can do smaller areas without spending the huge amounts that you do have to when you want to collect a satellite image, because there are restrictions in terms of a minimum order. Here's a little image we've pulled off of a satellite image, 50 centimeter resolution over Hoskote in Bangalore. I'm not sure if you can see my mouse, but there's a well here. And the next image is an image collected with our UAV. You can look at the, the quality of image compared to the satellite imagery. Advantages of a UAV versus a traditional aircraft. Flight duration. Well, full-scale aircraft, you got about 2 to 3 hours of flying time. UAVs, 45 minutes to 2 hours, depending on the aircraft and the batteries that we're using. With the traditional aircraft, you need to have a pilot as well as a co-pilot. The LiDAR sensor. With the UAV, it's pretty much one pilot with one support staff. Everything else is automated. Area coverage, traditional aircraft, you could do hundreds of square kilometers, whereas with the UAV, you're restricted to smaller areas. Operational altitude, we've got anywhere above 500 feet AGL. You're restricted from flying lower areas because of the Civil Aviation Authority. With the UAV, you cannot fly above a certain altitude because you're going civilian airspace. However, you do fly below. The resolution is quite an important thing with the traditional aircraft. Best resolution I've seen personally is about 5 centimeters, ranging up to 50. However, with the UAV, you typically can do 2 to 5 centimeters. You could go better, but then it's just it's a bit prohibitive in terms of cost and time frame. Capital investment. Traditional aircraft, an aircraft will cost you anywhere up to $2 million, whereas a UAV is anywhere from 6 to 20,000 US. The environmental impact, noise limits, uses aviation fuel when you're looking at a traditional aircraft, where no pollution, no noise pollution, no air pollution as well. Mission readiness is another important factor because aircraft do take time to mobilize and they do need to return to their base airfield after every survey, whereas a UAV can take off from pretty much anywhere. This is just the process flow that's followed. This is the one on the left is our acquisition process flow. We've got mission planning, pre-marking of ground control points, the actual survey of the ground control, launch of the aircraft, acquisition of data, and a field check of the quality of the data that has been collected. When you get back into your office to do the products, there's an aerial triangulation involved. DSM has to be generated, edited, verified. Then we go into a DEM, which is generated and edited. Orthomosaic, the mosaic is edited, and then you got your product where you can do your change detection and whatnot. That's a photograph of our Silver Bee UAS. It's just the guy is setting up, it's powered by an electric motor, fully autonomous flight, a modular nose cone, so anything goes wrong, you crash on your nose. It's just a matter of changing it over. We use a Li-ion battery, FRP body, including all the electronics and whatnot. The wings are with servo actuators. It's an electric motor, carbon fiber propeller. Details about our aircraft on the top right. Wingspan's 1.7 meters, over 3.5 kilos weight. We got an endurance of about 45 minutes, operating radius of 7 kilometers. Launch is automatic. Landing is with parachute recovery system. Flight mode is automatic with waypoints set up from the mission planning software. The business model for AIBLOB is One of the offerings is to build your drone, where we offer our customer that we would customize and build a drone for them. Generate products, and we also offer a maintenance and support system. The second offering, it would be to process the customer's data, where we'd operate and process the drone data for our customers. Again, choice of sensors based on what they want. So we've got GIS and image processing services, and training and documentation if required. The last thing that we do offer is build, operate, and process your data, where we would build the aircraft to your customer specifications, operate it for you, and process your data for you. So the aircraft's yours, but the operations and the product creation is all done by AIBLOB. Here's a little sample of an area in Bangalore that we've flown. Here's the orthophoto on the left and a zoomed in area on the right. So as you can see, the resolution is very, very high. I mean, I don't know if you can see it on your screen, but at the back of the house below the pink bougainvillea plant, you can see that they've got buckets lying in their backyard. So that's the kind of resolution that you can achieve using our UAV. High density point cloud, same area in Bangalore that we've flown. What you're looking at here are point clouds and not images. So it's all autocorrelated point clouds created from the imagery that is collected, and the points are attributed color values, which then gives you a colorized point cloud, as you can see. DEM, again, can be created. The orthophoto on the top right, a textured DEM, and you can see the other images. Finally, for mapping, we could also do 3D mapping, wherein we can do vector collection from the imagery. Because the orthophoto that's created is a true orthophoto, so you do not have building lean or issues like that that would give you positional errors. So you could do vector mapping off of the orthophoto if you want in 2D. There is an option to do the vector mapping off of the point cloud as well. So you could do 3D vector mapping if required. Now, before I go ahead with the rest of the just show you some of the data, and then I'll go ahead with the rest of the slides that are there. Now, what we've got here is a survey in Calcutta, which we've flown. It's a repetitive job. We are flying it once a month for our customer. They're basically monitoring the construction area that you can see here. What you're looking at here is the point cloud. This is not an image. I'll zoom all the way in. So as you can see, these are all points that have been generated using autocorrelation techniques from the imagery. I'll pan around this just so you'll get a look at the data. There's a little drainage ditch going along here. The construction area itself. There's the drainage ditch again. So as you can see, it's a very, very dense data set, the very dense point cloud data set that gets created. It's pretty much looks like an image. We've got a road. I'll zoom in here to show you that you can actually see the curb. I'll zoom out a bit. What you're looking at here are manholes on the side of the road. You can see one there. That's our team doing the actual data collection parked out there. Here's another manhole. Let me load the imagery up for you. If you look at the right hand side of my screen, that's the image of the manhole. So this data could be used by if they want to monitor, sewage lines, where do they have their manholes, where do they want to put in catch basins, or yeah, well, catch basins is the term I think everybody uses. Another Another benefit of using this is, let's say we want to do measurements. Let's look at measurements now. We're looking at measurements of that curve there. So we've got a point on the top of the curve. The elevation of that point is 40.57 meters. And if I take the bottom of the curve, let's see where the point's been measured, it's 40.42, which is 15 centimeters, which is pretty much the standard height for a curve. So measurements like that, pretty simple using the point cloud. Let's look at the width of the road. I'll show you how we do measurements of width of road. So you want to just check what the width of the road here is from bottom of curve to bottom of curve. We've got a line created. The length is 7.27 meters. So we've got an idea of the width. Anymore, I think I missed talking about trees. As you can see, the trees here. Usually the density of the points is so high that it's pretty much showing you, the imagery, the points show you the trees very well. Can be used for tree counting, can be used for canopy size measurements, health of trees. You can use this data set to check on health of trees. Now back to the drainage ditch. You can see the edge of the slope or the top of the ditch has been depicted very, very well with the point cloud. Now, if say we want to know what the depth of the ditch is, pick a point, an elevation of, let's see if I can find that here. It's on the edge. Sorry. So the elevation there is 8.68 meters. The bottom of the ditch is 6.71, so it's about 2 meters deep. If we needed to, let's say we needed to map this canal or drainage ditch, it's quite simple to take in a polyline and draw it off the point cloud. Don't mind the accuracy of my line, I'm just doing a rough one here for you to see what we're doing. So I'm drawing the top and the bottom of the ditch. And if I rotate that, the elevation of the line has been, the elevation of the vertices of that line has been taken from the point cloud itself. So when we pull this line data set out into any of the CAD softwares or my 3D polyline with the actual elevation in there. So this could be used for. Another interesting feature is the capability of doing volumetric calculations. If I can find a little pile of mud, let's look at this one here. To do the volumetric calculation, the cut value here, I'm just going to draw a polygon around the mound that we like to remove. If you look at the screen here, we've got a cut value of 3.7 meters cube. So that's the amount of earth that would need to be removed from there. So this can be used for a volume calculation like that. You can also use this for holes. This is just a mound that I'm showing you, but if I can find a hole in this data set, I think I had a hole in my hair. Yeah, there's this one here. Now, if you see the previous polygon that I measured gave us the cut value, whereas here, since it's a hole, we've got a fill value of 12.4 cubic meters. I'll zoom in and show you this from underneath, so you can see that it's measured the earth that's been removed. So you can actually, it's measured the hole itself, so it's telling you that the fill volume is 12.4 cubic meters. Another, let me show you how if we want to do a mapping of buildings, for example, again 3D mapping. It's just a matter of taking the polygon command, drawing in the edges of the building. If you look at that, the line's been drawn on the eve line. So any 3D mapping that we need, okay, that's gone up and taken a higher value because I hurried through it. We just need to drop that value point down there a bit. Measurements of length, breadth, height, as well as volumetric calculations. I will now show you, now if you look at, I'll show you the mosaic of this area. The imagery is 4 centimeter resolution, 4 centimeter GSD here. Zoom in a bit, that's probably the best. Anything more than that and we just get pixelated views. And I'll pan along. We've got setups for, I'm assuming those holes there are for light poles. I'm not really sure. We've got our manholes. Manhole there, another manhole there. The AIBLOB team flying from there. Let me show you the vegetation. Those are the trees. Now, using the point cloud or the orthophotos, our friends in the forestry department could do all kinds of calculations off of this. I'll show you the drainage ditch. You can see water bodies show up pretty well as well, and they can be mapped in 2D or 3D, however you prefer. Fence lines, buildings. There's a couple of people walking around here. It's too pixelated to make them out. The building under construction. So that's the construction area. I'm also going to just quickly show you a newer mosaic that we've done over this area, which was flown about 3 or 4 weeks ago. And you can look at the progress. And this is pretty much what our customer is looking for. He wants to look at the difference with this versus what's been achieved in the past 4 weeks. So you the orthophoto from the latest flight. This building looks really nice. If you look at the top of this building with the high resolution imagery that we are dealing with, we make out the AC, I'm not sure what the term is, but the little boxes on the rooftops which pull air in and blow the hot air out for air conditioning, central air conditioning. There's a lot of water because it just rained the day before we flew, so just don't worry about all the bright spots. Ideally, you need to fly it when the land is dry. Okay, and so that's pretty much the orthophoto of that area, the latest orthophoto. I would also like to just, another little data set that I'd like to show you guys is a railway that we flew. This was flown at a resolution of 2 centimeter GSD. What we're looking at is the point cloud again. I'm just going to zoom in and pan along. If there are any questions, feel free to ask. farms, because that's quite a big thing in India at the moment. There's a lot of solar farms coming up around the country. Well, for people who are setting up solar farms, ideally use a UAV, collect DTM and a DSM of the area of the proposed site to identify ideal locations for their panels. People with existing solar farms could use this to look at look at the imagery and identify any broken panels, stuff like that. We also offer offer a service where we could fly solar farms with a hyperspectral uh, with a thermal camera, sorry, pardon me, with a thermal camera where we could identify cold spots to see which are the panels that aren't working. With our quadcopter, this is flown with the fixed wing. So, but with our quadcopter, we also have the offer, we also offer a service where we could monitor power lines, the transmission towers. Again, I'm not or something like that's what they called along power lines. Insulators, I think they're called insulators, yes. We got our team standing here flying this aircraft. Before I show you the orthophoto of this data set, I'll do a couple of measurements. Now, if there are if there is anybody online from the railways industry, you'd know that the distance between the center of 60 centimeters, something like that. We have an option to do a measurement here. Well, what I've measured is 50 centimeters, probably off a little bit in my measurement, but you can do the measurements of sleeper widths. If you want to do the rail, we've flown a bit high for this, but I may be able to show you all the height of the rail itself. We're looking at, ignore the elevation here, it's showing a minus negative value, but that's because we haven't used ground control points on this project area. The client was more interested in the relative accuracy of the data set. So minus 117, there we go. That's probably not a good spot to measure this. Let's try here. 17.8. It's about 10 odd centimeters. So you can do measurements like that of rail. Let's look at we can do measurements of the width of the rail. I think it's about 1.7 meters. I think the standard width is 1.676 meters. Again, there's a few centimeters here is probably just my measurement, since I'm not really doing it very accurately at the moment. And that's pretty much it in terms of the point cloud. Oh, let me show you a curve here. This is a curve that we've got, very nice, well-defined curve. Top of curve, we've got an elevation of 114.6, and bottom of curve 114.8. So that's about, I think it was 6, 7, 7, 3, and 8. So about 13 centimeters was showing. So there's about 2 centimeters. That's probably just a before we close the data itself, I'll show you a mosaic of this area. Our actual area of interest is about yay big. So let me pan along, show you how good this is. Again, very handy when you want to do, count the number of sleepers, check for damaged ones, fencing. Panel. And so on. I think we've got a few. I'm not sure what that is. something to do with the railways, I guess. There's a little water tower, and the team standing there again. So that's pretty much it in terms of data. That's if there's any specific requests on something that you'd like to see, you could put that forward, and just close off. There's just a few more slides to go, so it won't take up of your time. AIBLOB has the option of doing power line surveys. So as I was talking about the inductors, you can check them with our quadcopter. You can fly in there, do video collection if required. We could do point clouds, which is up here. The point clouds, of course, would be a lot. Does take a bit of effort to create.
Muted.
But, yep. So we can collect point clouds. We can collect images. Inspection of the assets and so on. Not only restricted to power lines, you can also do windmills, you can also do cell phone towers, and any other assets that you guys can think of.
Muted.
Construction monitoring, as I showed you the data set there that we're doing for a customer in Calcutta. We can fly the construction area on a regular basis. Now in Calcutta, we're doing it once a month. We have another job we're doing where we're flying it twice a week, and basically monitoring the job from the time of excavation all the way through to completion of the building site. You can also do videos, eyes in the sky, videos of the construction site, just to give prospective customers or people who bought the property mines. UAVs are very useful when it comes to mapping of mines. It's probably one of the best tools that has come forward till today. Especially when in terms of doing an orthophoto where you can check the progress of the mining. You can do your volume calculations, the cut and fill calculations. You can do for safety. You can check for safety, check the since it's all roads cut into the sides of the mine, for lack of a better word, hole. Check that the road edges are fine and they're not going to collapse when someone's driving. Inspect an area, check that the guys have put the dynamite in the right places, stuff like that, and clear the team out. Post blasting, check that everything looks all right for the team to go back in. Check that all the dynamite has exploded and there's no unexploded ordnance lying around that could hurt any of our staff. We've got infrastructure mapping, like the road I was showing you. There's a screenshot of that down at the bottom. We could do so if you do, let's say we do 3D mapping off of the point cloud for a road. We've got 3D reconstruction, as you can see. And created a 3D file, 3D vector dataset that can be used by the planning department. You also have the capability of creating a sectional view because it's a point cloud similar to a LiDAR dataset, and so you could create sectional views of the area. It's with our LiDAR sensor on board, it becomes much more easier to use because you've got multiple returns and whatnot, like a traditional LiDAR sensor. However, today I'm pretty much focusing on the imagery aspect because that seems to be what's of interest to most people in India at the moment. Precision agriculture, with our new Prime Minister Narendra Modi, he's quite keen on helping the farmer to improve his farming methods, stuff like that. So high precision agriculture is a very big part of what UAVs can do and is being used worldwide at the moment. and that's something that AIBLOB is very, very keen on doing in India as well. While we're in agriculture, I might also mention that we are also looking at agricultural insurance, and we feel that, you know, since there are insurance companies that insure a farmer's um, ensures his yield and make sure that, you know, he doesn't lose out on anything and stuff like that. They need data that can be collected before they can make an assessment of the insurance, and you know how much to insure it for, whether to pay out on an insurance. You can do with NDVI imagery, crop density, water deficits, stressed crops, crops that aren't healthy, stuff like that. So pretty much everything like this can be done with UAV. For forestry, wildlife monitoring, down south here in India, down south where I am based at the moment, we've got a lot of elephant corridors where the elephants walk through the forest. You can monitor the migration of the elephants. You can monitor health. You can monitor the size of herds. You can, stuff like that. You can do an environmental impact assessment. For advertising, there's a lot of stuff for advertising that can be done, which is 3D modeling, inspection of sites where you want to erect large billboards. So they basically just survey for the planning and management of advertising sites, monitoring of the assets that have been installed on advertising sites like billboards, check that everything's fine, no damage to any of the no damage to any of the billboards itself, and so on. So that's pretty much it. I think I've covered all topics that I wanted to today. Just the last photograph of the construction. Thank you for joining in, and thank you to Geospatial Surveys for giving us this opportunity to present to everybody.
Muted.
Back to you, Sonal.
Thank you, sir. So there are a couple of questions. It says,
Yes.
What is the positional and vertical accuracy of the data captured from UAV?
Okay, so the positional accuracy is, let's say, like similar to traditional photogrammetry, where we talk about the accuracy in terms of pixels to within a pixel and a half or two. If we want to add in ground control points for geolocation on the Earth, it really depends on the ground control itself. But cater for the error in the ground control and maybe 2 pixels in the data set itself, and it gives you that kind of an accuracy. So horizontally, let's say, let's talk about relative only. Horizontally, you're looking at about 2 pixels at best. Vertically, about a pixel and a half.
Okay, and so the other question says, what is the accuracy?
Could you say that again? I didn't understand that.
So what is the accuracy the UAV will give for precision agriculture?
I see. Precision agriculture does not require high accurate data, as far as I'm aware. Absolute accuracy, anyways, is not really not really required, as far as I'm aware, in precision agriculture. This is something that I could check with the team and come back with an answer. But from my knowledge, I would say that they don't really look at very, very high accuracy. And let's keep in mind that today precision agriculture is being done using satellite imagery, which is at best 30 centimeter pixel size. We are talking down to 2 centimeters if required.
Okay, sir. So there's one question which says how UAV can help for asset management for power plant and mining industries.
Okay, let's the power plants. If I could get a little more clarification on this question, are we looking at the interiors or the exteriors of the power plant?
So interiors.
Interiors. Okay, we to fly an aircraft, because there's a lot of structures in there and stuff like that. So I would not say that we could fly an aircraft inside inside the building itself. However, IBLOB has also got another product which is in development, and we hope to release it to the public in the coming months, where we have developed this specifically for interior monitoring. It's not a UAV. That's all I'm at liberty to say at the moment. It's not a UAV, but it will collect 360-degree imagery and generate point clouds, which can be used for monitoring. Now, if you're looking at the exterior of the power plant, exterior of power plant, power lines, transmission towers, any of these kind of things, it's really, really simple to fly one of our quadcopters, because we have the capability of hovering. When you fly a fixed with a rotary wing, you can hover in one place. So you've got your camera looking at the asset. We can collect a video, collect photographs, and bring that data down, or stream it if required. It can be streamed down to the ground so that whoever's operating the aircraft can see what the camera is seeing, and that can be used for monitoring assets. Going to mining, in mines, again, I don't know if we meant underground mines, so go underground where a UAV would not it would have to be the new product that we're developing. If you're looking at the exteriors, we can use the UAV to monitor, like I was saying, blasting. That is one of the things that could be used for monitoring. We can monitor the slopes. You can monitor pit walls. You could, you monitor the amount or the quantity of earth or materials that has been removed from the mine, and you could also use UAVs for managing your fleets and the movement of materials.
Mapping of power.
Yeah. Power lines?
Power line transmission corridor. How much route length can be covered in an hour by a UAV?
With a good resolution data set, let's say about 5 to 7 kilometers. However, in saying that, it depends on how, what's the resolution that a person requires. Like, let's say you want a high resolution photograph of the power line. We could do about 7 to 8 kilometers in an hour. This is any of these estimates that I'm saying today are, of course, dependent on weather conditions. So, like, let's say you're going to 5 kilometers an hour, and good days more than that.
Okay, sir. So there's a question that can this UAV used for land records, which require very precise data?
Yes. If you're looking at mapping a data set from the UAV data, you can collect, again, like I said, the accuracy of our data is 2 pixels. So let's say we've flown, flown at a ground sampling distance of 2 centimeters a pixel. Since it's land record, I'm sure we would need to go to we would need to add ground control points as well. So for land records, let me go back to one of my point clouds or orthophotos. Let's look at the orthophoto. As you can see here, that's a fence. It's not a wall. It's just a regular wooden fence, which is very, very clearly visible on 4 centimeter imagery. So you can map anything that's visible on the ground using UAV imagery, and the accuracy is 2 pixels.
Okay, sir. So I'll be taking the last question. It is how UAV aircraft is beneficial than LiDAR-based survey?
Are we talking about terrestrial LiDAR, mobile LiDAR, or airborne LiDAR?
So it's airborne LiDAR.
Airborne LiDAR. The first thing is cost. The cost, if you're going to use an airborne LiDAR, is that you need to bring in a traditional aircraft. So as I was saying earlier, you've got mobilization costs, you've got hangarage costs, you've got to have an airfield, pretty, within about say 30 odd kilometers from the survey area. So you get little restrictions that way. Whereas if you use a LiDAR sensor that's attached to the UAV, you don't have any of those restrictions. It's pretty much a matter of just going onto site, flying it, and landing. So that's a benefit of using a UAV LiDAR. The cost, however, using a UAV LiDAR would be more than using an RGB camera or an RGBI camera. And cloud is that vegetation would not. You'd get the top of vegetation, you wouldn't get the ground beneath vegetation. Using a LiDAR, you would get a last return which returns off of the ground.
Okay, sir.
And sorry, let me just add one last thing to add to that is, like, if we create a DSM from the imagery, you're looking at let's say a 3 centimeter GSD image, you can do up to 1,000 points per square meter. If you're flying with the LiDAR sensor, you could at best get 150 to 180 points a square meter.
Okay, sir. So there are a few more questions. We'll share it with you, and you can reply to them through the mail of the people, because there are plenty
Certainly, sounds good.
On the budget and everything, and what will be the price and all.
Sounds good. Thank you so much.
Okay. Thank you, sir. Thank you all the participants for joining the webinar today. We will have the recording of this webinar placed in our webinar archive for reference and viewing it at later date. Thank you for joining us today. Keep you posted on our further activities at our online portal. Thank you.
Thank you.